In this video, we are going to continue our look at corrosive materials by looking at some specific types of acids. So when it comes to acids, again, remember our Arrhenius definitions. Our Arrhenius definition said that an acid is something that produces hydrogen ions in water. And so when it comes to those, there are really three types of acids that can exist. There are the binary acids, sometimes referred to as mineral acids. What is striking about these is these are acids that do not have oxygen in their chemical formula. And these are also acids that can exist in the gas phase as molecular compounds outside of water. So in order to become corrosive, in order to actually have acidic properties, these acids must first be dissolved into water. So a real common example of a binary acid is hydrogen chloride. Now, hydrogen chloride gas is a substance that is not salt. It is a covalent compound, and it's also non-acidic in the gas phase. However, as soon as it comes into contact with water, it dissolves into that water and turns into hydrochloric acid, which is extremely corrosive and very highly acidic. It's a very strong acid. Now, the second type of acid is another common kind of acid known as an oxyacid. Oxyacids are acids that contain oxygen and usually contain some other kind of inorganic element material as well. So, carbon, sulfur, phosphorus, selenium, chromium. These are common examples of elements that combine with oxygen to make oxyacids. And we get some really interesting chemistry out of a lot of them. So some real common examples we mentioned before: sulfuric acid, strong acid; perchloric acid, another strong acid used in the explosives industry; and then phosphoric acid, which is most commonly found in beverages, in particular colas and certain types of sodas. And then the last type of acid is the organic acid, sometimes referred to as the carboxylic acid. And the reason for that is the carboxyl group, the carboxylate group here, is featured prominently in all organic acids. So if you see an organic substance, and so this R group here just represents some kind of carbon and hydrogen chain, if you see a end group on an organic substance that has a carbon double bonded to an oxygen and then a carbon bonded to an OH, that is an organic acid. And so organic acids tend to just have carbon, hydrogen, and oxygen in them, but the real key aspect there is the carbon. It has to be just carbon, hydrogen, oxygen. And we get this carboxylic group as a result. And so there's some interesting examples of carboxylic acids, but we're not going to talk about too many of them in this course, because the majority of the acids that we encounter are actually oxyacids. So some common examples of these oxyacids: things like nitric acid, which is found in fertilizers, found in explosives. You've got sulfuric acid. That is the acid part of your car battery. So if you open up your car battery, you'll find a series of lead plates, and they're all in this solution of sulfuric acid. And the sulfuric acid is providing the medium in which the electricity can be conducted through those lead plates. Phosphoric acid, as I mentioned before, is found in a lot of different types of soda, especially brown cola sodas. Hydrochloric acid is found in toilet bowl cleaners, in particular those brand name is the Works. Perchloric acid is found in the fireworks industry and is also a precursor used in a lot of explosives. And then acetic acid is found in vinegar, and it can also be found in wine if the wine has started to turn. So if you've ever noticed that you open a bottle of wine, it tastes good the first day, and you put it in the refrigerator and it tastes okay the second day, but by the end of the week it's pretty much trash. Well, there's a reason for that. What's happening there is that the fermentation process, the process by which the sugar in the grapes gets turned into alcohol, ethanol, has continued to take hold and take place. And what we're getting is the fermentation now going further into the realm of turning the alcohol and turning the sugar into vinegar instead of just the alcohol. And so that's why it begins to taste bad after a certain period of time. Now, what do we know about acids in general? Well, we know that they have electrolytic properties. Strong acids have strong electrolytic properties and conduct electricity very well. Weak acids conduct electricity poorly, but still do conduct electricity. We know from our experiences that they taste sour. Um, we know that they will conduct electricity. We know that they will turn blue litmus paper red. And we know that they will neutralize bases. Bases sometimes referred to as alkaline substances. Now let's flip it around and look at some common reactions. Now, we know that acids are capable of reacting with skin. We know that they are capable of reacting with metals. What kinds of metals are they capable of reacting with? Well, pretty much every metal. There's some exceptions in there. Copper really only reacts with strong nitric acid. Otherwise, it doesn't really react at all. It needs something to oxidize it. Silver, gold, and mercury are relatively inert metals as far as chemical action and reactivity are concerned. In some cases, that's really good. That's why silver and gold jewelry is made and is made to last. We know that acids will react with metallic oxides. We find metallic oxides often in dirt, in ores. And so if we want to extract metal from the ore, we need to react it with acid. And so the process causes the oxide to degrade, and we end up getting a metallic salt, which we can then plate out into the purified metal, and we get water. And the whole process there is something called pickling. We also know that acids can react with metallic carbonates, and when they do so, they will produce carbon dioxide, water, and ionic compounds. When they react with your skin, depending upon the concentration and the exposure time, you can see a number of different things happening. The first thing, and you've probably all experienced this in some kind of way, a chemical burn, where the site of contact just appears to be a little bit red, maybe a little bit itchy. With prolonged exposure, you can actually see skin blistering, where the acid will actually distort the skin and start to cause some minor tissue damage. And then with even longer exposures and even higher concentrations, we can see permanent disfigurement and irreversible damage to the individual.